Hello, future toppers. Let's make maths simple, intuitive, and fun together. So, we got wholesome new problem which says if f of x defined from this to this, okay, then f of x is. So, this question is talking about continuity and differentiability and differentiability at x equals to 0. Okay. So, first we will try to define the function. So we have f of x equals, first I will talk to x smaller than 0. So for this case I have to replace this mod x with, the x is negative, so minus of x. Okay, so can I write x times e power minus of 1 by x plus of 1 by x. So this thing gone, so it will become 0. So e power 0, x times e power 0 will be x. Okay, then at x equals to 0, it is 0. Then x greater than 0. So if x is greater than 0, we will have x times e power minus into 1 by x plus 1 by x. So it is x times e power minus 2 by x. I hope till this part you guys are comfortable. Now first we will talk about continuity. Okay, so for continuity we will talk to LHL, limit x tends to 0 negative. So you have to substitute 0 over here. So this thing will become 0. LHL is 0. Then f of 0 is 0 already. Then we have to talk to RHL. So we have RHL equals to limit x tends to 0 positive. So x is 0. So 0 times e power minus infinity. Okay. So it is 0 again. So given function is continuous. Hence it is continuous at x equals 0. I hope till this part you guys are comfortable. Now we have to think about differentiability. Okay. Now for LHD we have to differentiate this function. Okay. So LHD. So differentiation of x becomes 1. Now RHD. Okay, so first we'll do differentiation of this function and then we will substitute 0. Okay, so we will keep first function as it is, means x as it is, e power minus x by 2 by x, 2 by x, and then we will have minus of 2. Okay, I'll make it more simpler. Look, I will replace this thing, x times e power minus 2 times x power minus 1. Okay, now look at this. So we will keep this function as it is, e power minus of 2 by x. Now we have to differentiate this. So it is, first you will have a constant minus 2. Now x power minus 1. Now x power minus 1 will be written as minus 1 in the coefficient, x power minus 2. So it is 1 by x square. Okay. Now plus e power minus 2 by x, and then differentiation of x becomes 1. Okay. Now this x gone. So can I take e power minus 2 by x common, and then we will be left with what? 1 plus 2 by x. Now be super slow, substitute x equals to 0. So this person will become what? E power minus infinity, that is 0. Okay, so 0 into anything will become 0. So RHD is 0, LHD is 1, RHD is 0. So the given function is continuous at x equals to 0, but it is not differentiable at x equals to 0. I hope the idea is clear and you guys can handle similar situations. So see you guys in next session of MathFlix.